Okay. So sorry, we left off and we were replacing the point 3, -2 into this first equation, 3x plus 2y equals 5. So we plug in 3 for x and we plug in -2 for y, and we end up getting 3 times 3 equals 9 plus 2 times -2, that equals -4, is supposed to equal 5. So now we have 9 minus 4 equals 5. That is a solution for the first equation. Now let's try 3, -2 for the second equation, which is 6x plus 4y equals 10. So we can do 6 times x, which is 3, plus 4 times -2, which is y, is supposed to equal 10. We have 6 times 3, that's 18, plus 4 times -2. Well, yeah, we could just write it like this. 18 plus -8 equals 10. 18 plus -8 does equal 10. So again, the only way that we could plug in two different solutions into both of these equations and have both of the solutions be true with both coordinates is if these two equations actually describe the same line. So there was a little verification. Now it's time for you to get ready to take some notes. We're just going to summarize, even though it may feel repetitive, we're going to summarize the major takeaways from lesson 27 so far. So based on our work, we now know that the systems of linear equations can have one solution. And again, this is probably great to put onto a cheat sheet for your unit assessment, just the way that you're writing it down right now. We can tell that a system of equations has one solution if the slopes are different. And that means that the lines intersect in exactly one point. At one point. Again, we've seen that there can be no solutions. That's when slopes are the same. Intercepts are different. These describe parallel lines that will never meet. And then the last possibility is infinitely many solutions. In this situation, the slopes are the same. Intercepts are the same. This means that it's the same line. All right. If you need some time to write this down, pause the video, get it written down into your notes. We're going to continue with another example. We'll call this example 2. And this is specifically an example where graphing isn't precise for finding a solution. So okay, so sometimes the graph shows two lines intersecting, but the exact intersection point is hard to read from the grid. And several of you have asked about this in class. And I'm gonna write up the equation that I actually just began to struggle graphing a moment ago. So our example system is y equals 3x plus 5 and y equals 8x plus 3. So we need to graph these points before we can see what this example looks like. So I'll make sure that I have my graph paper going the right way. The first equation is 3x plus 5. I had my straight edge, and now I don't know where it is. So 3x plus 5. This equation here, how do we know where to start? We look at the y-intercept. For the first equation, it's 5. And let's see. I'll make this first equation green. And I'll make the second equation red. Hopefully that shows clearly on the graph. So again, first equation, 3x plus 5. Go up 5 from the origin. And the 3x part tells us that our slope is rise over run. If our slope is 3, then that's the same as 3 over 1. And that's a positive slope, so we want to make sure that our line is tilted, looks like it's sloping upward as we look from left to right. So we'll go up 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. So again, if you don't have a ruler, you can just fold up a piece of paper to make a straight edge. That first line is y equals 3x plus 5. The second equation is 8x plus 3. So we'll go up 3 from the origin to plot the y-intercept. And then we need to go up 8 over 1. So, right, because the slope, let's do this again. We know that slope is rise over run, and if we have 8, that's the same as 8 over 1. So from our y-intercept, we'll go up 8 over 1. 1, 2, 3, 4, 5, 6, 7, 8 over 1. And again, this is a positive slope, so we want to make sure that our line is tilted up as we are looking left to right. And then you're not even going to be able to see it. So I'll just stick with these 2 points here. I was going to plot another point down below, but it won't be on camera. You only need 2 points to graph a line. And the second equation is y equals 8x plus 3. Okay. Now, if I had to say, I would say their intersection point between these two lines, I would say that the x is somewhere between 0 and 1, a little less than half. So maybe, I don't know, 4/10, which is the same as 2/5. So for the x, I would guess that the solution is maybe 2/5 for the x term. And then for the y term, let's see, I would say it's a little bit more than, well, a little less than 6.5. So maybe 6 and 2/5. But that's not very exact. And this is not a clean or neat intersection point right here. Sorry, I'll make this intersection point a little bit bigger. This is where I see the lines crossing. And it's not really clearly a whole number on the x axis, and it's not clearly a whole number on the y axis. So we have these kinds of fractions. If we want the exact solution, though, we can do something that's called solving algebraically. So the first method or the first strategy that we're going to try is called substitution. So if we look up here at these two equations, the ones that are in the system that we just graphed, both of these equations are set equal to y. That means that we can set the right-hand sides equal to each other. That means that we can set this expression, 3x plus 5, equal to this expression, 8x plus 3. And just so that you can see why, imagine that you know that a equals y, and you know that b equals y. If you know that a and b are both equal to the same thing, then because of this thing called the transitive property, we know that a equals b. So if you have these two equations that are both set equal to y, that means that we can set these equations equal to each other. So what does that look like? We have 3x plus 5 equal to 8x plus 3. And now what we're trying to do is solve for x. So you guys have heard me say over and over again, you can choose which side you want to get the variables and the constants on. In this example, it looks like it'll be easiest to get the constant or get the variables, sorry, on the right side. So I'll subtract 3x from both sides. The positive 3x and the negative 3x cancel out. We can bring down this 5. We get 5 equals 5x plus 3. We can subtract 3 from both sides to get the constants off of the right side and all together on the left side. The positive 3 and the negative 3 cancel out. 5 minus 3 equals 2. 2 equals 5x. And how do we get this x by itself? We have to divide by 5. So we end up getting 2/5 equals x, or let's just rewrite it so it looks neater. X equals 2/5. Okay, so what do we do now? Well, because we solved for x, we can plug x back into either one of these original equations, and we can solve for y. And this x and the y that we solve for is going to tell us exactly what this coordinate is. Because again, it's hard to tell when you graph. So instead, sometimes we have to solve algebraically. And the first strategy that we're trying is substitution. So we will rewrite the first equation. Let's go with y equals 3x plus 5. So y equals 3x, that's 2/5. Plus 5. And now we should simplify this equation. This 3 is actually over 1. So we have y equals 3 times 2 in the numerator, that's 6. 1 times 5 in the denominator. Y equals 6/5 plus 5. Now, it's really, in order to add this whole number and this fraction, hopefully you remember that we need to have a common denominator. And because this is a whole number, we know that the denominator for this number is 1. 5 and 1 are not the same. These fractions don't speak the same language. In order for them to speak the same language so that we can add or subtract them, we need to find a common denominator, and we can just make 5 the common denominator. So this first fraction stays 6 over 5. Now to change 5 over 1 into a fraction that has 5 in the denominator, we multiply the denominator by 5. But that means that we also have to multiply the numerator by 5 in order to make an equivalent fraction. So we have 6/5 plus 5 times 5 in the numerator, that's 25, over 1 times 5, that's 5. Now we can add these fractions because they speak the same language. So 6 plus 25 in the numerator equals 31. When you add fractions, the denominator stays. So our y value is 31 over 5. So now we take this x and this y, and we put them together for an ordered pair. That's a solution to this system of equations. So the solution to this system is x equals 2/5 from right here, and y equals 31/5. We just solved for that through substitution. So this ordered pair is the solution to this system of equations. And let's see if this corresponds with the graph. So does it seem like the x term is 2/5? Yeah, I think I might have said 4/10, which is the same as 2/5. So that was a pretty good guess. And then the y term is 31 over 5. Well, let's see, 31 over 5. We can just turn this into a mixed number. 5 goes into 31 6 times with 1 left over, so 6 1/5. Does this seem like 6 1/5? About. So yeah, again, that was our first algebraic method for solving a solution to a system of equations, and that's the substitution method. It's much more precise than what we saw in the graph. Now we're going to look at a third example. A third example problem, a second example of substitution. Example 3. This is substitution without two matching expressions. Okay, so we'll start with these two equations, y equals 7x minus 2. And the second equation is 2y minus 4x equals 10. Now, do these lines have the same slope or do they have different slopes? In order to compare, we need to have two equations that are in slope-intercept form. This equation is in slope-intercept form, but this one is not. So we need to get it into slope-intercept form. We can do that over here. We'll just rewrite the equation right here. 2y minus 4x equals 10. We need to get the y term by itself on the left side. So we need to add 4x to both sides. The negative 4x and the positive 4x term cancel out. We'll bring down the 2y. 2y is equal to 4x plus 10. Now we need to divide across the entire equation. We need to divide by 2. And we get these 2's cancel out. Y equals 4 divided by 2 is 2. Y equals 2x. 10 divided by 2 is 5. Y equals 2x plus 5. So now we need to compare these equations. I'll rewrite the second equation as y equals 2x plus 5. So, do these lines have the same slope or different slopes? They have different slopes. So we can go ahead and continue with this method because we know that there's just one solution. Sorry, different slopes. We know there's just one solution. So we know what y equals from the first equation. So we can substitute this expression 7x minus 2 into either this equation, into this equation. So again, when we were given this system of equations, one of the equations was already set equal to y. So what we're going to do is we're going to take this expression and we're going to plug it into this equation. So this is what that looks like. So we have 2y. So we have 2, and where we see y, we're going to replace it. We're going to substitute it with this expression. So we have 2 times 7x minus 2. And then we're going to continue with the rest of the equation. Minus 4x equals 10. And now that we have the equation rewritten with y substituted with this expression, we can go ahead and evaluate this equation. The 2 on the outside of this expression means that we're going to apply the distributive property. So 2 times, well, actually, I'll just rewrite it so it's a little bit easier to understand. We have 2 times 7x minus, and the minus sign comes from right there, 2 times 2 minus 4x equals 10. So now we can evaluate and simplify. So 2 times 7x, if you have two 7x's, you have 14x. 2 times 2 equals 4. So 14x minus 4 minus 4x equals 10. We can collect like terms, and you have a 14x and a negative 4x here. So that equals 10x minus 4 equals 10. We want to get the x term by itself because we're trying to find out what x equals. So we're going to add 4 to both sides. 10x equals 14. And now we can divide each side by 10 to get x by itself. And we'll get x is equal to 14 over 10. And if we simplify, it's something that we've been practicing in class, you asking yourself, what can I factor out of the numerator and the denominator? We can factor out a 2 from the numerator and the denominator. 14 divided by 2 is 7. 10 divided by 2 is 5. We have x equals 7/5. Now, just like in that last problem, now that we've solved for x, now we can plug now we can plug 7/5 in wherever we saw x in our original equations. So we will use this original equation, y equals 7x minus 2. So we have we're using this equation, y equals 7x minus 2. So y equals 7 times x, which is 7/5, minus 2. So now when we evaluate this expression, it will tell us what y equals. So remember, when we have a whole number multiplied by a fraction, we can put the whole number over 1 and then multiply across. So we get y equals 49 over 5. That looks like an S. 49 over 5 minus 2. And like in our one of the previous problems from this lesson, we can't subtract a whole number from a fraction, not until we've turned this whole number into a fraction. So every whole number is a fraction over 1. And now we are looking to see, can we subtract this fraction from this one? We can't, because these fractions don't have a common denominator. So we need to find a common denominator. We can make it 5. So we're going to keep the first fraction like it is. We don't need to find an equivalent fraction. But if we're going to make an equivalent fraction with the denominator of 5, that means we multiply this denominator by 5, and we multiply the numerator by 5 also. So we get 49 fifths minus 2 times 5, which is 10. 49 fifths minus 10 fifths. When you subtract fractions, you subtract in the numerator, but not in the denominator. 49 minus 10 equals 39 over 5. So what is our ordered pair? We have our x term from our first substitution move and our y term here. So now we just need to write them in an ordered pair. This solution is 7 fifths and 39 fifths. I made a mistake. Sorry, this is not our solution yet. Not yet. So, yes, we do. Sorry, I just got confused in my notes. Undo the erase. Our solution is 7 fifths and 39 fifths. Again, I'm going to make mistakes in these videos. You guys are going to make mistakes in the work. It's okay. It's all right. There's another substitution example. One more. And this is just, we'll call this substitution strategy 3. All right. So we have 2 equations. We have 4y equals 26x plus 4. And a second equation, y equals 11x minus 1. So in this system, we know what y equals, so we can replace y in the first equation. So that means that we're just going to replace this y with this expression. So we have 4 times y, which is 11x minus 1, equals 26x plus 4. And now we need to evaluate and simplify. So we'll use the distributive property. And you don't have to write it out like this every time, but just for those of you who still get a little confused by the distributive property, we'll add this extra step. We have 4 times 11x minus 4 times 1 equals 26x plus 4. 4 times 11x equals 44x. Minus 4 times 1, that's 4, equals 26x plus 4. Subtract 26x from both sides. Get a little double digit by double digit subtraction here. Can't subtract 6 from 4, so we've got to borrow some 1s. Now we have 14 minus 6, that equals 8. 3 minus 2, that equals 1. We have 18x minus 4 equals 4. So add 4 to both sides, add 4, add 4. You get 18x equals 8. There's so many steps to this problem. Now we divide both sides by 18, and we get x equals 8 over 18. Or if you've been paying attention, we're going to factor out or simplify this fraction so that we have something smaller. We'll factor out a 2 from the numerator and the denominator. That gives us x equals 4/9. So now we have our x term. And what are we going to do with this x term? We're going to substitute it into one of our equations above to find out what our y term is. And we're going to substitute it into the shorter equation, y equals 11x minus 1. We're going to replace the x with this x that we just solved for. So it's y equals 11x minus 1, y equals 11x minus 1. So here we go with these steps again. We've got to multiply a whole number by a fraction, and then we're gonna have to find some common denominators so we can complete our subtraction. But let's start with multiplying the whole number by the fraction. The whole number is a fraction over 1. Now we can multiply these fractions. We get y equals 11 times 4 in the numerator, that's 44. And in the denominator, we have 1 times 9, that's 9, minus 1. Can we subtract 1 from 44/9? Not yet, not until they have the same, not until these fractions or these terms have the same common denominator. So 1 is a whole number, and we know that every whole number is a fraction over 1. And so we have 44/9 minus 1/1. And in order to find a common denominator, we can multiply each of the denominators by the other. And that's going to get us to have a common denominator of 9. So in this first equation, we're only multiplying, or sorry, with this first fraction, we're multiplying the numerator and the denominator by 1. So we end up with 44/9 minus, we're going to multiply the denominator by 9, so we can have 9 there. And since we multiply in the denominator, we also multiply by 9 in the numerator. We get 9/9. Now we can subtract because we have two fractions that have the same denominator. So y is equal to 44/9 minus 9/9. This is equal to 35/9. That's what y is. So now we have an x value and a y value, and we can put them together. And the solution to this system of equations is the ordered pair 4/9 and 35/9. Whew. This point is where both lines intersect. So I am actually going to allow you all to practice exercises 4-7 on your own. If you need some support with them, you can reach out to me in tutoring. Run back this video and the first half of this video as many times as you need to so that you get a good handle on what lesson 27 is asking from you. Again, I appreciate the time that you put into watching the video. It's definitely helping you. I can tell it is. Yeah, keep up the good work, and I'll see you in class.